Hello, this is Jack Jackson. In this video, we start our week 7 of History of Mathematics. This week, we're going to be talking about medieval European mathematics. My typical sources are lectures of Todd Timmons, History of Mathematics by Carl Boyer, History of Mathematics by Victor Katz, and the MacTutor History of Mathematics, among other places, but those are the main sources. So we're going to start today by introducing medieval European mathematics and talk about some of the basic things. This picture is of a medieval university, which is one of the advancements of medieval period in Europe. I believe this one is in Italy, Pisa, actually. So let's talk about the Roman Empire and Christianity just a little bit. After the establishment of the Roman Empire, the Roman rulers valued practical applications of mathematics, but they didn't have as much use for more higher mathematical ideas. Governmental support for scholarly activity, including work on advanced mathematics, began to wane in the empire, resulting in the slow decline of mathematical advancement. And ultimately, even though they held on for some time, it brought an end to the millennium of classical Greek mathematics around the beginning of the 5th century Common Era. In the 4th century, Constantine became emperor of the Roman Empire and moved his capital to Constantinople, which he named after himself, formerly known as Byzantium and presently known as Istanbul. He converted to Christianity late in his life, and then Christianity became a recognized religion in the empire. After the death of Constantine, the empire was split into an eastern Byzantine empire centered at Constantinople and a western empire that still had Rome as its capital. The western portion of the Roman Empire in particular fell into decline from a number of factors. Among them were including attacks from outside by a variety of folks the Romans considered as barbarians, but they included the Huns, led by Genghis Khan, among others. By the end of the 4th century, the Western Roman Empire had collapsed. And although the Eastern Byzantine Empire survived for another millennium or so. So in Western Europe, the Western Romans mixed with the Germanic peoples and some of these various invaders mixed to form a new society that was more feudal system in Western Europe. And the feudal system, there was not a lot of travel and commerce, and not as much mathematics there either. Meanwhile, over a period of centuries, the Christian religion became the dominant one in the Roman Empire. During the 2nd to the 4th centuries, Christianity spread throughout the Roman Empire, and it became the official religion of the empire in 395. The bishops of Rome became more and more powerful and ultimately becoming the popes. As the Christian church became more centralized and more powerful, it began to dismiss outside knowledge as irrelevant at best and dangerous at worst. And once again, this fundamentalist attitude helped to slow the progress of many intellectual areas, including mathematics. Christian religion and theology, Greek philosophy and learning, and Roman government and culture combined, along with some Germanic influences, over the centuries to ultimately provide the foundation of European culture. During the Renaissance, this combination would ultimately prove to be the foundation upon which Europe would build modern mathematical advances. However, for centuries there was a lull in academic advancement in Europe. And during these dark ages, mathematics advancement in Europe slowed considerably. And the Dark Ages term, as we've discussed, really applies to Europe more than other cultures because we know at this same time there was the golden age of mathematics going on in China. This is where most of the Indian mathematics that we discussed was taking place. And of course, the Islamic culture was making great advances in mathematics at this time. So while the Islamic culture was undergoing this mathematical growth, and sort of a renaissance of ancient knowledge and adding to it, European mathematics was pretty stagnant. And years of war and diseases such as the Black Death also did not help mathematical progress any. So the medieval period or Middle Ages goes roughly from the mid 5th century to the mid 15th century, marking a period between early periods of the ancient world and the Renaissance, which followed the medieval period and produced the beginnings of modern culture. Traditionally, historians mark this period from the fall of the Western Roman Empire, which they date at about 476, to the fall of Constantinople to the Turks in 1453. However, in a history of mathematics, Karl Boyer suggests the dates of 529, when the schools in Athens were closed, as the date to end the ancient period and start the medieval periods. And then he suggests 1436 as the end of the medieval period because it's the probable date of the death of Al-Kashi, who is a very prominent Islamic mathematician at the House of Wisdom in Baghdad. And it also happens to be the date of the birth of Regiomontanus, an important European mathematician of the Renaissance. So it's just kind of a convenient date to pick there. But regardless, you can see we're talking about mid-5th century to mid-15th century. During the early years of the Middle Ages, the progress of mathematics in Western Europe stagnated and even slid backwards in cases. However, in the Byzantine Empire, efforts were made to preserve some ancient Greek knowledge, although really little progress was made beyond it. Meanwhile, recall the Islamic mathematicians were making the most numerous and significant advances in mathematics on the planet at that time. So, what about coming out of the Dark Ages? Well, despite this decline, the quadrivium, arithmetic, geometry, music, and astronomy, all considered part of mathematics, were still respected for the education of the elites. That, along the trivium, were considered the basic curriculum. At the European universities, which were founded in the late 11th century to early 13th century, and especially in places like Paris, Cambridge, Oxford, several in Italy, and so forth. Latin was the scholarly language throughout Europe. It was the language of the Romans, and it was preserved as the language of the church. And since it was the language of the Christian church, the Catholic Church, then it by de facto became the language of scholarship. One of the things that did drive some work in mathematics were calendar considerations. Calendar considerations have always had some effect on making mathematics grow because there's this problem of trying to reconcile lunar calendar and a solar calendar, and the fact that these things don't work out as a whole number of days or nice ratios. And there's always some desire to try to date certain religious events. Our current calendar is actually the Gregorian calendar, and it wasn't put into place until 1582, although some earlier versions of it were around a little bit before that. In the 10th century, we begin to see a little revival of interest in mathematics in Europe. Gerbert Daalrek, so this would say, the Daalrek would say where he's from, Gerbert would have been his name, lived from about 945 to 1003. And he later on became a pope. And when he became pope, he took the name Sylvester II. That happened in the year 999. But before that, when he was younger, he studied in Spain. And in Spain, he came into contact with Islamic mathematics. And he was the first to introduce Hindu Arabic numerals to Europe. Although they were not really accompanied with the full understanding of computational algorithms for using them, and they didn't really take off right away, nevertheless, he inspired some renewed interest in mathematics. Over a period of time, European scholars were to gain knowledge and skills preserved and expanded by the Islamic culture, and this occurred in places where there's a mingling of cultures living in the same area, such as Spain, in certain trading centers, and in places like in Italy, where there's a lot of sea trade, and of course also in the western part of Europe, where the Islamic Empire and Europe kind of came together. Now, Spain in particular became an important part of this. because in Spain we had the area going back and forth between Muslim hands, Christian hands, and there was a large Jewish population there too. But the Muslims in Spain were particularly um, open to accepting Jews and Christians, and so there was a mixing of the cultures there, and that's where a lot of transmission of ideas happen, such as with Gerbert. I mentioned the emergence of the European university. If you see from about the 12th century to the 15th century here, you can see when certain universities were founded. And for example, Oxford was in the 13th century and Cambridge as well. When you're looking up in Scotland, we're talking in the 15th century. Let's see where are some other interesting ones. Down here in Spain, you see some in the 13th century. Italy, there's some earlier ones. There's a 12th century one there. Naples there, Rome, for early 14th century, Pisa, 14th century. Um, Different places there as well. Paris, 1257. Vienna, 1365. Leipzig, 1409, and so forth. So you have different European universities coming online in those days. And of course, the European universities will ultimately be the center of learning in the Renaissance. And notice that there wasn't just sort of one center, like one major center like Alexandria or Athens or Baghdad. That there are a lot of these places, a little more decentralized, but each of these were to be very important, especially as we go further on into the Renaissance. One of the things that was important during the Middle Ages was the transmission of Islamic mathematics to Europe, and really the transmission of earlier Greek works through by way of the Islamic mathematicians. And the 12th century finally saw a European interest in Arabic works of mathematics and earlier Greek works too. So European scholars started translating mathematical works from Greek and Arabic to Latin. And one of the most significant of these translators was uh, Gerhard of Cremona, 1114 to 1187. He was an Italian, but he lived and worked in Spain. Once again, there's that uh, Spanish connection. He translated or oversaw the translation of 80 important works, including the Elements and the Alchemist, which we studied earlier. Jewish scholars played an important role in the transmission of mathematical ideas in the Middle Ages, particularly in Spain. And in fact, some works were first translated from Arabic to Hebrew, and then maybe from Hebrew or Arabic to Hebrew or Spanish by a Jewish scholar, and then someone would translate from, maybe a Christian scholar might translate it from Spanish into Latin. Sometimes that happened. But one of the Jewish scholars was Abraham ibn Ezra, or Era, excuse me. No, it is Ezra. Okay, there we go. Ezra from 1090 to 1167. And transmission of ideas from Islamic mathematicians to Europe proceeded in spite of the Crusades. During some of this time, there were holy wars between Christians in Europe with the Muslims in the Middle East. And while that you think that might open up some communication there, those folks weren't communicating very well. In fact, that probably um, the Crusades probably actually um, held back trade routes and so forth. But nevertheless, mathematics ideas definitely were translated. Like I said, a lot of that happened in Spain. By the beginning of the 13th century, many Greek and some Arabic works were finally available in Europe to study. The next video, we're going to look at some specific mathematicians from this period in this area.